Hey everyone, and welcome back to the EdgeVerse TechCast. This is your trusted source for everything NXP software, tools, and enablement. I'm your co-host, Kyle Dando, and today we're covering one of my favorite engineering sidekicks. It's the NXP Config Tools. You can think of them as sort of Batman's Robin for our NXP MCUXpresso IDE tools.
And I'm your other co-host, Bridgette Stone. I might be slightly obsessed with these tools, don't judge me, but by the end of the episode, we think you'll understand why these utilities are game changers for embedded development.
All right, Bridgette, I won't judge you, but to help us break it all down, we're joined by a good friend, Petr Hradsky. He is the brains behind the Config Tools. He works with a great team in Brno, and he'll introduce himself. He's got firsthand knowledge of how these tools save time, reduce errors, and streamline your workflow.
Petr, thanks for joining us. Why don't you start by telling the listeners a bit about yourself and how the team in Brno got started with all this?
Hi, it's a pleasure to be here. I'm Petr Hradsky, and I lived in Brno, which is the second biggest town in Czechia in Central Europe. We have a long history of developing software tools with our team here. It originally started many years ago, and we started as a small startup company, and we had a product called Processor Expert. After some time, we became part of the Freescale Corporation and later NXP.
Well, thanks for being here, Petr. And I know out of all the tools NXP offers, I feel like Config Tools has the most straightforward name. But let's set the record straight. What exactly are the Config Tools and maybe what they are not?
The config tools are a suite of tools in one application. They can help during the embedded system hardware and software design and implementation. We actually provide two flavors of this product. We provide MCUXpresso Config Tools for microcontroller developers and Config Tools for iDynamics, which is a product for application processors. You can get them free of charge as desktop application for download on our web, or you can use the online version directly on the web. If you are using MCUXpresso IDE, which is our development environment, you can get the config tools directly integrated inside this IDE. Also popular is MCUXpresso installer for VS Code, which provides easy way to get the correct tools when you are using the VS Code editor.
Yeah, we need to make sure it's real easy for our listeners and the customers to get those tools. So Petr, you might not know this, I was a hardware engineer in the Bay Area. I was responsible for configuring the devices on our hardware platforms so that the software teams could get started. And so I can easily relate to how the requirements of the configuration are handled by your tools. None of them more important that I've spent time with than the pin tools. The software team really relies on the hardware team getting those pins properly set up. So how does the NXP config tool really help in getting this important task completed?
Yeah, definitely. The pins tool can assist in many ways. When you are a hardware engineer and you develop a new product, you can use the pins tool to explore the possibilities of the connections on the chip package, because there can be multiple of them, and you can check the availability of signals from individual peripherals. Let's say you have a rough idea that you need a specific number of UARTs, SPI buses, PWM outputs, whatever you know, and you'd like to ensure that it's actually possible.
As you mentioned, the chips today make it so much more challenging for developers because most of the chips are multifunction and multiplexed. So the permutations of the configuration possibilities are endless. So keeping track of that is really valuable, and it can be really difficult for the engineers.
Yeah, that's correct, Kyle. Also, as you are routing the pins, you can add labels and see the used and free pins graphically on the package diagram. This can help in tracking those things. And the pins tool can instantly check potential conflict, so you can ensure that it's possible to route the chosen pins to peripherals. And after you are satisfied with the pins configuration, you can pass the safe configuration to your colleague who is developing the software, and he would really appreciate it. We have received feedback from our engineers that are working with the customers that the pins tool is very useful for cooperation between hardware and software developers. And there are even more possibilities. for further sharing the pins configuration. You can create HTML report with a table of pins or export the table of external signals as a spreadsheet file.
So, Peter, that must be a great way to assist the communication between the hardware and the software engineers. But once that is shared, what can the config tools do for those software engineers?
If you're a software developer, the tool provides you the generated C code with functions that initialize the pins to the state determined by what you configured in the tool. The preview of such functions in the source code is available after each change, highlighting how the changes influence the code. So you can call these functions from your code or select those that will be automatically called at application startup. And afterwards, when you are writing the application code using the pins, you can refer to the pins using the identifiers that were provided by the hardware guy, or you provided them in the configuration.
Peter, I've heard great things about how the configuration tool helps with our evaluation and our freedom boards. Can you explain to the listeners how the tool is great for working with these boards?
When a customer is using a board from NXP, we have a nice feature that's for visually showing the expansion headers of the board. You can discover how many pins are connected from headers, and you can even interactively change the routing without the need to look onto the schematics. This can save really a lot of time. And I remember myself when I was spending a lot of time exploring schematics and looking for PDFs and searching how the connectors pins are connected to the MCU package. So all this can be done even using web-based tool without actually installing the desktop version of the config tools.
Excellent. Same with you, Peter. I had many days where I was squinting at PDF files, trying to find port names, trying to figure out if I could make the font larger on those symbols so you could properly configure the device. So having it in a nice, easy to view web tool is really powerful.
Well, speaking of things that can make or break a design, timing is everything, literally. So let's talk clock setup. It's one of those things that feels simple until you actually have to do it. There's so much going on behind the scenes, PLLs, dividers, and constraints. How does the clocks tool help developers make sense of all that without losing their minds?
The modern microcontrollers have many options for timings and clocks. It's important for having power consumption, computation speed, and timing accuracy under control. So there can be multiple sources of clocks, like multiple PLLs, dividers, which can result of billions of possible configurations. And sometimes this can be too much for the developer.
It sounds like a puzzle with a million combinations and only one right answer.
Exactly. But our clock tool provides a graphical representation that shows the structure of the clocks on the chip. However, this is not only seeing the structure, the diagram is interactive and you can configure individual elements and see what happens in the rest of the diagram. What are the frequencies? And also you can see what values will be written to control registers in case you are interested in such low-level details. And the whole state of clocks is validated against the constraints of the hardware. And the tool immediately shows the problem when the configuration wouldn't work on the real chip. It's much faster than trying it on the hardware. In case you don't like to configure each individual element, you can just specify it and log the desired frequencies at selected clock output and let the clocks tool do the job, searching the appropriate states of elements like selectors, dividers, PLLs. After the solution is successfully found, you can see the results and the impact of each change to the whole clock structure and resulting frequencies and preview of the generated code. You can create multiple alternative clock configurations, and the tool generates initialization C code function for each of them. And it's up to you which of these configurations you actually use in the application code.
I'm sure our developers very much appreciate that. It's not only visualizing the config, but validates it too. No more trial and error guessing on the hardware. That's a major win.
And Peter, one thing that me and my team have seen when comparing your clock configuration tool with some of the competition is it doesn't limit the settings. Some of the other microcontroller clock configuration tools, they may seem at the top level as very intuitive, but when people try to take advantage of the chip, sometimes they're locked out of specific settings and they have to go in and manually update the code. So kudos to your team to provide engineers a very easy to use tool, but something that can really get down into those complex timing requirements without them having to break out a data sheet and manually modify code. Okay, now it is time that we touch on the support customers will find for adding and setting up peripherals. So Peter, why do customers need the peripheral tool? We talked about the clocks and the pins, but what complex steps is the tool simplifying for the developer when they're trying to capture peripheral setup?
The NXP MCUs contain a lot of interesting peripherals, and the peripherals tool provides a way to simplify and speed up the configuration of them. We provide a comprehensive SDK library with the drivers, but it may take some time to get familiar with the possibilities, and that's where the peripherals tool takes the place. You just select the peripheral that you would like to use, and the tool automatically adds the necessary configuration component into the project. You can select the mode, settings for the peripherals, and the tool generates the initialization code with pre-filled data structures and a function calling the appropriate SDK API needed for the proper initialization. If you have a toolchain project linked to the configuration, the tool checks if the proper SDK components are in the project and that they are in the proper version.
So Peter, this sounds like your team has been providing sort of an AI code generation for customers for years. Working with these new AI tools, it's effectively doing what you're saying, which is understand the project requirements, look at the chip resources, and then properly set everything up for the customer. This isn't artificial. It's Czechia.
Love it.
Yeah, but there is more. If you have selected a peripheral in the components, the peripherals tool cooperates with pins and clocks tools and checks the proper configuration of pins and clocks related to the selected peripherals. And it can detect problems like unrouted pin signals or disabled clocks. But this would be quite tricky to identify just by looking at the code. Without it, you might not identify those mistakes until you actually try it on hardware.
Okay, so that means less late nights in the lab trying to figure out why the clock is missing or the pin has no output. What else, Peter? Keep us going.
Yeah, the tool can also help with configuration of DMA transfers and channels in case the component operates in DMA mode, which is sometimes complex things because there are sometimes complex relationships between triggers and DMA channels, etc. And you can see an overview of the channels showing which component is using which channels, for example.
This has all been so helpful, Peter, but now I've got to ask, what's the latest shiny object your team has been working on? Anything new or exciting on the roadmap?
We continue working on improving all configuration tools, but if I should name one topic, it would be the support of configuration of the Zephyr RTOS. This real-time operating system is becoming more and more popular in embedded systems area, and we'd like to provide tools helping to easily customize the hardware configuration in the Zephyr. There was already introduced support in the pins tool earlier this year. You can select that you are creating Zephyr configuration, and the pins tool generates the pin control device tree includes for you. Anyway, this is still in the beginning, and we would like to provide users more than that. So we are now focusing on adding more and more capabilities related to Zephyr.
That's a really big deal. And I know Zephyr's gaining a lot of traction right now. So having our config tool support is perfect timing.
Exactly. So to recap, today we've explored what the configuration tools are, why the pins and the clock tools are essential, how the peripheral tool saves time and headaches, and we even got a glimpse into the future with the Zephyr support that your team's putting together. That's a lot of value packed into this one episode.
Yes, it is. And a big thanks to Peter for sharing his insights and for all the work your team does to make embedded development so smooth.
Thanks for having me. It was great to be on the show and talk about my favorite tool suite.
Well, if you like this episode, don't forget to subscribe, leave a review, and hit that notification bell so you never miss an episode.
And until next time, keep innovating, everyone, and we'll catch you on the next EdgeVerse TechCast.